Okay, so welcome to this video where we'll be doing question D, 1D. Okay, so now this will be interesting. So question D reads, the three blocks of hexadecimal numbers are 24, 45, 37. Then another block, as you can see here, we have a comma, so that's 64, 44, A1. Okay, and meaning the last block we have 3B, then 2209. Okay, so as you can see, we need to hash need to be hashed in order to get the checksum so that the information they contain maintains integrity. So from that point, let me explain something. So these hexadecimal numbers, they are unique, meaning when we hash them, we end up with one unique answer which is now hashed to represent a certain checksum. So a checksum is just a number which is there to verify the integrity of the message, or it means that the information has not changed or was not altered during its transmission. In other words, it wasn't tampered with. So what we are doing is we are creating a checksum or a hash from these three block letters or hexadecimal numbers. So calculate the checksum using hexadecimal numbers. So first thing you need to understand is hexadecimal numbers themselves. So we have hexadecimal numbers. Let me explain that. Hexadecimal numbers. Okay, so hexadecimal numbers go up to 16, but they start at 0. So we have 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So as you can see, from 0 up to 15, if you count all these numbers, they add up to 16. So that was the meaning. Now starting from 10 up to 15, we represent those numbers with letters from the alphabet. So we'll start at A, B, C, D, E, and F. So that's why on these block numbers, you are seeing certain letters on them. So that's the meaning for hexadecimal numbers, and soon you understand on how to calculate them. So first of all, let me go back to the question. So you see how these numbers were arranged in this order, but representing them, you need to represent them like this. You get the first block, which is this, you display it like that. Then you get the second block, then display it like this, just under that first block. The last, you get the last block, then you display it like this for you to come with this normal order. So now you can start. So you make a list of hexadecimal numbers, then you can now start adding. But before we start hexadecimal numbers, we are only interested in the remainder. So now if you understood about the mode or how we came up with the remainders from the previous video, you can understand this part easily. So we are interested in the remainders, so here we'll be putting remainders, not the whole number. Okay, so then remainder and whole number. So I'll represent this like that, whole number. Okay, now we can start. You understand? Okay, so we'll be adding the same way we do our addition. So we have 7 plus 1, which is 8, plus 9, which is 17. Okay, so we have 17 now. So we have 17 like that. So for us to know the remainder, if we have 17, you need to understand one thing. This hexadecimal number add up to 16. So we need to divide it by 16, the same way we did with the previous RSA calculations. So if you open up your calculator, if you say 17 then divide by 16, it's 1 point something. So if you divide by 16, again we just get 2 decimal places, it's 1.06. So we are getting 1.06 like that. So meaning from this, the whole number is just 1. So the whole number is 1 like that. Remember, so 1 like this. So this represents the whole number. Then the remainder now, remember we need to get rid of the decimal places, then you multiply by the denominator, which is 16. So 1 times 16, again we get 16. From that we now need to say this same 17, which was the numerator, minus 16, which is this answer we have at the bottom, for us to know the remainder, which is now 1. So 17 minus 6 is 1. So the remainder is equal to 1. Okay, now I'll repeat. This is one way you can find the remainder and the whole number. But in other terms, for you to find the remainder, you just need to say 17 minus 16, which is this one. But we are doing this for us to gain full marks. So remember, we said we are interested in the remainder for this answer. So the remainder is 1. So here I'll put 1 at the bottom to represent that remainder, which is this one. It's the one we are seeing. Now we have this one, which is the whole number for this remainder, this whole number. Like we are saying, how many times does 16 go into 17? It's just 1. So you get that one and put it on top of this second addition you want to make. So you put the 1 on top like that. So now it will be, the next addition will go like this: 1 plus 3, which is 4, plus a, our a is 10. So plus 10 we get 14, because it's 1 plus 3, 4, plus 10, 14, plus 0, still 14. Now 14 is within this range. As you can see, our 14 is E. So there's no need for us to calculate for the remainder and whole number. You just say E. But if you want, you can do that. So you just say E like that. So for the first block, we are done like that. What's happening? Okay, so like that we say E. Okay, now let's go to the next one. So we have 5 plus 4, which is 9, plus 2, 11, as you can see, our 11 is B from this. So here we need to say B. So just a second. Okay, like that. So we get B. Then now we need to say 4 plus 4, which is 8, plus 2, we get 10, which is our A. So we say A. Like that. Okay. Now we have 4 plus 4, which is 8, plus B. So our B is 11. So 8 plus 11, we get 19. Okay, so since 19 is not within this range, we need to show. Okay, so we have 19. Remember, hexadecimal numbers go up to 16. So you need to say 19 divided by 16. So we get up to 2 decimal places, which is 1.18. So let's do that. Then from that we'll get rid of the decimal places, then say times the denominator, which is 16. Again it will be 16. Like that. Then we get the numerator, which was 19. We say minus 16, the answer we are from obtaining, which is giving us 3. So in this case, our R, which is the remainder, is 3. But the whole number, as you can see, is 1. So the whole number for this one, again, is 1. So what we mean here is that how many times does 16 go into 19 is 1. So the whole number which will be added here is just 1, like that. Wait. Okay, the whole number will be 1. So the whole number will go on top of that next addition. So our remainder, remember, is 3. So the easiest way for us to let me put it in normal. Okay, the easiest way for us to know the remainder is to say 19 minus 16, that's 3. So now how many times does 16 go into 19? That's the whole number, which is 1, which is now on top of that next addition. So now we have 1 plus 2, which is 3, plus 6, which is 9, plus 3, which is 12. What's 12? That's C. So we put C there now. So we are officially done with this question. So as you can see, for hexadecimal numbers, we are interested in the remainder and the whole number. So the remainder goes at the bottom after you do your additions. For example, we said 7 plus 1, which is 8, plus 9, 17. So how many times does 16 go into 17? We said it's 1. Wonder we are putting 1 on top like that because it's the whole number. Now, what's the remainder for 17 divided by 16? The easiest way is to say 17 minus 16, which is 1. Wonder we are putting 1 here like that. Then you continue the same process like we have done. So if the number is within this range, you just get that same answer and you add it like that. So that's it for this question D. Hope you understand. It's a little bit complicated, but just take your time. So this is Soko James representing cyber security tutorials for KMU. See you in the next video, which is now question 2A. Okay.